What's going on, everyone? Welcome back. Patrick here, and in this video what we're going to talk about is measures of central tendency versus the symmetry of a distribution. So I'm sort of going to take the last two videos that we did where we talked about both of these separately, and I'm going to kind of combine them. So to do a quick little review, measures of central tendency, remember we went over three of them. Went over the mean, the mode, and then the median. And then the symmetry of a distribution, there was three cases. There was the distribution when it was symmetric, when it was skewed left, or negatively skewed. And then the other case was when it was skewed right, or positively skewed. So let's go over each of these cases and talk about how it's going to affect these three measures here. So the first case is if the distribution is symmetric. So I'm going to draw a density curve of a symmetric distribution. Basically looks like that, where there is that even number of low and high values. That frequency for both is the same. And with a symmetric distribution, really simple, the mean is always going to equal to the mode, which is always going to equal the median. Because there's a perfect amount of observations on that left and right side. So the mean, the mode, and the median is going to be this point right there. And notice that it is definitely the mode because that's where the peak is. Right? So with a symmetric distribution, it's pretty easy. Mean equals mode, which is equal to the median. Now, the second case is if we have a distribution that is skewed left or negatively skewed. So if we draw that out, distribution that's skewed left, meaning that peak is going to be that peak is going to be on the right side. So it's going to be like that, kind of. Right? So that tail extends out to the negative side or to the left side. Now, with these two cases, when a distribution is skewed left or skewed right, when we're comparing the mean, mode, and median, what I like to always remember, the median is the middle. It's always going to be in between the mean and the mode. So you're going to get either two cases. You're either going to get the mean being less than the median, being less than the mode, or you're going to get the mode being less than the median, being less than the mean. But the median is always going to be in the middle of these two other measures, the mean and the mode. You can kind of remember it because it's a median, that middle value. And so if I know that, then what I like to do is I like to look, where is the peak? Is the peak on the far right or is the peak on the far left? And I know the peak always represents the what? The mode. So in this case, notice that the mode is on the far right, right? So that's where the mode is going to be. And so next is going to be the median. And so out in the tail is going to be the mean. The mean is always out in the tail that extends for a skewed distribution. And so if a distribution is skewed to the left or negatively skewed, that's going to be the relationship of the three measures, right? The median is always going to be in the middle, and then the mode is always where that peak is. And since the peak is to the far right for a skewed left distribution, then we got the mode, we got the median, and then we got the mean, and that's the relationship between them. And then the third scenario is if we have a skewed right distribution or a positively skewed distribution. So if we draw that out, we know that that peak is going to be on the left side, and then that tail kind of extends out like that. And remember, the median is always in the middle of these three. And where's the mode in this case? It's where the peak is, which is on the far left. So the mode is on the far left this time. Then we have the median, which is in the middle of them. And then we got the mean. And remember, the mean is always out in the tail. So when a distribution is skewed right or positively skewed, the mode is less than the median, which is less than the mean. Now, one thing I want to mention, notice that from a skewed left distribution and a skewed right distribution, notice how that mean is kind of always getting pushed out to the tail, as I've mentioned. And what that means is that the mean is less resistant to outliers. It's less resistant to outliers, meaning it's going to be affected more by outliers. If it's less resistant to something, then it's being affected more by it. While a median, notice that it's closer to that bulk of the data. So even if there's outliers over here, the median is still going to be closer to the bulk of the data, which means that the median is more resistant to outliers. And so a lot of the times the median is actually a better measure with skewed data, as long as that data is large enough. Right? So I want to mention that. I can actually show you it through an example. Let's say that we have, let's write out a couple of observations. Let's say we had 4, 6, 8, 10, 12. So we have 5 observations in some kind of data, whatever this would be. Notice that, what's the mean going to be here? Well, if we add all of this up, you'll have 10, 18, 28, 40, and then 40 divided by 5 observations would give you 8. And notice that the median is 8 as well, that middle term. Right? We have an odd number of observations, so there's going to be a single middle term. But now, let's say that instead of a 12 here, what I'm going to do is I'm going to put, let's say, a 32. Right? What effect is that going to have? Notice how that is obviously an outlier from this data here, because most of the data is kind of centered around this 8, and then this 32 is way far off. Notice what the effects are going to be here. So this is without an outlier. That was the original data when we had the 12. And now let's do it with the outlier. So what's the mean going to be? So the mean is going to be 18, 28, 60 divided by 5, which would give us 12. But what's the median going to be? Notice the median isn't going to change. 8 is still going to be that middle value. And notice that with this outlier, the median is a better representation of the central tendency of this data. Notice the bulk of it is over here, and then we have this outlier here. Versus the mean, it got pulled from 8 to 12 because of this outlier. And so that doesn't really give us an accurate picture of where that central tendency is, where that bulk of the data is, kind of outside of that bulk of data. Right, so that's just a small example. It's more pronounced when you have larger data sets. But yeah, just an example of where that mean is less resistant to outliers. Notice we added an outlier here and the mean changed, but the median stayed the same. And so the median was more resistant to outliers. It was affected less by outliers.